In the silent vastness of space, a golden mirror opens like the petals of a flower against the dark. This is the James Webb Space Telescope, humanity's greatest time machine, designed not just to look outward, but backward. Every time its polished eyes capture light, it carries us deeper into history, reaching across 13.5 billion years, toward the dawn of creation itself. At first, scientists expected to see faint sparks, the fragile beginnings of galaxies, barely formed, chaotic clouds of gas and dust. But what appeared on Webb's detectors stunned the world. Hidden in that ancient light were galaxies already massive, bright and organized so early in time that, by all our understanding, they had no right to exist. One astronomer compared the sight to opening a baby album of the universe and finding a fully grown adult staring back. These galaxies were too developed, too soon. According to the cosmic timeline we have trusted for decades, such structures should have taken billions of years to form, not mere hundreds of millions. And so a puzzle was born, one that shakes the very foundation of our cosmic story. If the universe's first chapters are not what we thought, then perhaps the entire script of creation must be rewritten. Science thrives on questions, and here was a question too vast to ignore. How did these galaxies come to be so quickly, and what do they mean for our understanding of time itself? This documentary is the story of that enigma, a story of discovery and doubt, of wonder and confrontation, and of humanity's relentless drive to peer into the unknown and find its truth among the stars. The dream of the James Webb Space Telescope began as more than just an upgrade to Hubble. It was conceived as a machine for time travel, a window through which humanity could gaze into the universe's earliest chapters. Engineers and scientists envisioned a telescope capable of detecting light so faint and so stretched by the expansion of space that no instrument before it could ever hope to see. To achieve that, Webb would need a mirror large enough to capture whispers of light, instruments cooled to near absolute zero, and a vantage point far from the warmth and glow of Earth. It would be humanity's boldest attempt to watch the universe being born. For decades, Hubble had been our eye in the sky, orbiting just above the turbulence of Earth's atmosphere. Its images reshaped our vision of the cosmos, towering nebulae sculpted by starlight, galaxies tangled in collisions, and the iconic deep fields showing thousands of galaxies packed into a single frame. Yet Hubble had limitations. It was built to see primarily in ultraviolet and visible light, the same range our eyes detect. While powerful, this left it blind to much of the infrared spectrum, where the earliest galaxies hide. Light from the first stars had traveled billions of years, stretched into deep infrared by the relentless expansion of the universe. Hubble, as revolutionary as it was, could not fully unlock that hidden realm. That is why Webb was needed. Infrared vision is not a luxury. It is essential for looking back in time. Every beam of starlight carries history, and the farther it travels, the older the story it tells. To astronomers, light is more than illumination. It is a messenger from the past. Catching that light means catching the moment when the first stars flared, when the first galaxies began to coalesce. Webb was designed to capture these messengers, to translate their faint glow into a narrative of cosmic origins. Before Webb, our timeline of galaxy formation was well established, or so we thought. The story went like this. After the Big Bang, the universe expanded and cooled, entering a long, dark age. Then came the first stars, igniting the cosmos with ultraviolet light. Small primitive galaxies slowly emerged as clusters of stars bound together by gravity. Over hundreds of millions of years, they merged and grew into larger galaxies, eventually resembling the majestic spirals and ellipticals we see today. In this framework, mature galaxies, massive and organized, should not appear until at least 500 million to 1 billion years after the Big Bang. This was the model passed down through decades of observations, theories, and simulations. It was the cosmic script written before Webb's golden eyes opened. But as the telescope began to peer into the darkness, it returned images that didn't match the script. Instead of fragile newborn galaxies, Webb revealed giants that seemed impossibly ancient for their time. The timeline was broken, and with it, our certainty about the early universe. The James Webb Space Telescope is unlike anything humanity has ever built. Its most striking feature is its golden mirror, a dazzling array of 18 hexagonal segments that together form a surface more than 6 meters wide. Coated in gold to enhance reflection of infrared light, this mirror acts like a giant ear pressed to the universe, catching faint whispers from the dawn of time. Infrared eyes allow Webb to see what our own cannot. Light stretched by billions of years of cosmic expansion. Light that carries stories from the very first galaxies. Its instruments must be kept colder than the freezing void of space. Shielded by a tennis court-sized sunshade that blocks the heat of the sun, Earth, and Moon. Every design choice was made to transform Webb into a time machine, its sensors tuned not to the present, but to the echoes of creation. When the telescope first turned its gaze into the deep past, astronomers braced themselves for faint, fragile galaxies, small sparks in a young, chaotic universe. Instead, Webb returned something few dared to expect. Images revealed galaxies surprisingly bright and surprisingly massive, shining from a time barely 300 to 400 million years after the Big Bang. One researcher remarked, "We were expecting toddlers, but we found grown-ups." The surprise was not just visual beauty, it was a scientific shock. According to the standard cosmic timeline, the universe's history should have been gradual. After the Big Bang came the Dark Ages, when matter cooled and the first atoms formed. Then came reionization, when the first stars blazed into life, illuminating space. Only after hundreds of millions of years should gravity have sculpted galaxies, merging and assembling them piece by piece. Mature galaxies, spirals or large ellipticals, were expected much later. But Webb was showing structures that appeared far ahead of schedule. How do astronomers know these galaxies are truly ancient? The key lies in redshift. As the universe expands, light from distant galaxies is stretched, its wavelength shifted toward the red and infrared end of the spectrum. By measuring this redshift precisely, astronomers can calculate both distance and age. Webb's sensitive instruments confirmed that these galaxies were not nearby imposters, but truly ancient giants, shining from the earliest epochs. The evidence was not a trick of the eye, it was real. The implications are profound. If galaxies of such size existed so early, then either stars formed at an astonishingly rapid pace, or our models of cosmic evolution are incomplete. Some scientists wonder if dark matter, the invisible framework of the cosmos, behaved differently in the early universe, pulling gas into galaxies more quickly. Others speculate that physics itself might need revision, that perhaps some unknown force accelerated star and galaxy formation. Still others caution patience, noting that early data may carry uncertainties. Could some galaxies be misidentified, their brightness mistaken for mass? Could dusty, energetic newborns masquerade as mature giants? These questions have sparked intense debate. In conference halls and late-night discussions, scientists wrestle with the mystery. One astronomer admitted, "We're standing at the edge of a puzzle that may force us to rethink how the universe built itself." Another countered, "Extraordinary claims need extraordinary evidence. We must be cautious before rewriting the laws of physics." What is clear is that Webb has already disrupted the cosmic story. Its golden eyes have revealed galaxies that challenge our assumptions. And whether the explanation is rapid growth, exotic physics, or observational illusion, the universe is not yielding its secrets easily. The debate is ongoing, the science unsettled, but the excitement is undeniable. Each new Webb image arrives not just as data, but as a challenge, a reminder that the universe is stranger, richer, and more unpredictable than we dared to imagine. The discoveries made by the James Webb Space Telescope strike at the very heart of modern cosmology. For decades, the Big Bang timeline has served as the backbone of our cosmic story. First, the birth of space and time, then the cooling of energy into matter, followed by the first sparks of starlight, and much later, the majestic spirals and ellipticals we see across the night sky. But Webb's revelations pose a direct challenge to this sequence. If large mature galaxies existed just a few 100 million years after the Big Bang, the timeline may need rewriting. This doesn't mean the Big Bang is wrong. It remains the best explanation for the universe's origin, but it suggests our understanding of what happened next is incomplete. The script of cosmic evolution suddenly feels like a draft with missing chapters. Among the most pressing mysteries is star formation itself. To build massive galaxies so quickly, stars must have formed at a pace beyond anything our models predict. Could the first stars have been vastly larger and shorter-lived, burning bright and collapsing quickly to seed galaxies with new material? Or did conditions in the early universe allow gas to collapse more efficiently, sparking waves of star birth? Webb's images of these early giants reveal an urgency in the cosmos we never anticipated. The universe, it seems, was in a hurry. The implications ripple outward. Dark matter, that invisible scaffolding holding galaxies together, may have played a stronger or more complex role than we imagined. Perhaps it pulled matter into dense structures at breakneck speed. Dark energy, the force driving the expansion of the universe, might also be connected in ways not yet understood. Each new Webb discovery sends shockwaves through physics, threatening to topple dominoes that reach far beyond astronomy, into the very foundations of how we think the universe works. Scientists are divided, and that division is healthy. In research papers and conferences, the reactions range from skepticism to exhilaration. Some argue the data are preliminary, that errors in measurement or misinterpretations could be to blame. Others insist the evidence is too strong to dismiss. If these galaxies are real, one astronomer noted, then something in our models is broken. Another countered, "This is the thrill of science. We are standing on the edge of discovery, and we don't yet know which way it will lead." Debate fuels progress, and Webb has given the community a reason to question, to argue, and to push deeper. But beyond the halls of academia, the meaning reaches us all. Webb's findings remind us that the universe is not a static textbook, but a living mystery. For humanity, this changes how we see our place in the cosmos. We are part of a universe that may grow faster, evolve quicker, and surprise us more often than we believed. It's humbling to realize that even our most trusted theories can be shaken by a few faint specks of light. Yet it is also exhilarating, a reminder that the cosmos is larger than our imagination, and that our quest for understanding is far from over. The James Webb Space Telescope has revealed galaxies that shouldn't exist, yet there they are, shining defiantly from the universe's earliest moments. They challenge our cosmic timeline, daring us to question what we thought we knew. Their very presence is a reminder that the universe does not bend to our expectations. It tells its own story, written in light that has traveled billions of years to reach us. Science, at its core, is not about having all the answers, but about asking better questions. Webb's discoveries do not represent failure. They represent progress. Each unexpected galaxy, each puzzling signal, forces us to refine our models, to expand our imagination, and to accept that the universe is more complex than our equations can capture. One astronomer put it simply, "We are not tearing down the house of cosmology. We are discovering hidden rooms, and Webb's journey is only beginning." Beyond galaxies, its instruments are poised to probe the atmospheres of distant exoplanets, searching for chemical fingerprints of life. It will study the birthplaces of stars, the chemistry of cosmic dust, and perhaps glimpse light from even earlier than we dared hope, the universe's first flickers after darkness. Every observation will push humanity deeper into questions of origin, destiny, and possibility. As we stand under the night sky, it is humbling to remember that our story is bound to these discoveries. Webb is not just a machine in space, it is an extension of our curiosity, our longing to understand. The galaxies that should not exist remind us of the truth. The cosmos is always ahead of us, waiting to surprise, to challenge, and to inspire. Our quest is endless, but that is what makes it beautiful.